Please welcome our next speakers, Douglas Santos and Hossein Jazi, both working for Fortinet. Douglas here is Director of Advanced Threat Intelligence and Hossein is a Senior Threat Intelligence Specialist. Both speakers have much experience to bring in here, from tracking state-sponsored actors to understanding malware and managing these threats on the strategic level. I do welcome both of our speakers here as they will talk about and show us a little bit on how advanced threat actors are weaponizing Microsoft Common Console files for stealthy attacks. It will be a technical deep dive, so bear with me and please everyone, blow very hard right now to your screen because we will need to blow away the demo gods and Mr. Murphy as they will try to do a live demo. Please welcome everybody. Please welcome those two great speakers, Douglas and Hossein. Thank you very much and enjoy the show.
Thank you so much. Can everyone hear me clearly? Good. So thank you. I'm Douglas Santos. And today we're going to be exploring some of the research we have been doing over the past year and a half or so, where we identify threat actors leveraging legitimate Windows tools and subsystems to achieve initial access and execution on organizations. And for me, looking at this, it's surprising to see how underutilized these techniques are, just because they're so easy to implement, they are hard to detect once they are executed on the environment, and then can be very enticing for the user just because there is a way to basically change the icon on those files. And it's very, very easy for a non-tech-savvy user to fall prey to those specific techniques. So we're going to be exploring this on the next couple of slides. Myself, I'm Douglas Santos. I've been in cyber for 25 plus years. I've been working for Fortinet for over 10 years now. And I know my title is kind of fancy, but there's a logical explanation to it. So I'm mainly focusing on advancing threat intelligence when it comes to new methodologies, new standards, and tooling. So I'm working with MITRE CTID, which is a research organization that is responsible for the attack framework. And working with them, we joint develop those new methodologies, new tooling, or new techniques so that we are able to capture the evolution of threats as they happen. And once the project is completely ready, we open source for the whole community to use. And then my work begins internally in Fortinet to make sure that I can deploy these technologies inside our products, in the backend processes for cyber threat intelligence processing, right? So my main focus is threat researcher. So I look at threats, I see how they fare against technologies that we use internally or on products. I'm working with partnerships in Fortinet as well, and I'm doing evangelism, presenting conferences, and I'm basing out of Vancouver, Canada. And I'm working with this handsome fella here, Hossein.
Thank you. Hello, everyone. I'm Hossein Jazi, a Senior Threat Intelligence Specialist at Fortinet. My main passion and background is on monitoring and tracking threat actors, especially nation-state ones. If you heard about threat actors like Evasive Panda and Lazy Scripter, these are the threat actors that I initially identified and named them. As part of my research, I do malware reverse engineering, APT attribution, and I'm passionate about blogging and presenting at conferences. And recently, I became interested in cybercrime investigation. I'm part of several groups in which we work with our partners to track and take down cyber criminals. And I'm excited to be here and present our research.
Yes, thank you, Hossein. So let's talk a little bit about MSC files and weaponizations. So MSC files, if you've been around Windows enough and you ever had to do any troubleshooting on Windows, you used it without even knowing it was there, right? So it's known as Microsoft Saved Console files. Those are basically XML files that are open by a legitimate Windows binary called MMC, which is Microsoft Managed Console. So if you ever had to, edit the registry, create a new service, delete a service, look at certificates, looking at logs, looking at the disk of your machine, you used it already, right? But even when you're opening those very legitimate Windows tools, because those MSC files and the MMC, they tap deeply into Windows internals and data structures that are critical for the correct functioning of the operating system, the MMC and the Windows subsystem will throw you a warning saying, hey, we are about to, this application is going to make changes to your devices. You know what you're doing. This can, make or break your system. Are you sure you want to open this? And then you click yes. And then you are presented with MMC, opening the MSC file, which is an XML file, tapping into different Windows subsystems so you can manipulate those to your need, right? So a lot of specific things happen, and we're gonna show you what's happening when this is abused, right? So I think I have to click on this video here. Yes. So as I can show you guys here. This is just what are the contents of the MSC file. As you can see, it's just text basically. It's an XML file, and one of the things that researchers identified was that there is a way to call a DLL that has an XSS vulnerability from the MSC file. And when calling this specific DLL and abusing this vulnerability, you can execute code. And as you guys saw, there was no warning at all, right? I mean, I could just click on that. I got execution. There was no warnings, not anything. And that's because of the way this vulnerability inside apds.dll works, right? So you can see here how it's being exploited. In this case, it's an innocuous POC. We use this to test our own defenses, but I'm tapping into the Windows subsystem. I'm using MMC, but no warnings at all. It's just downright execution, right? One of the most interesting things about this is that when you're building detection rules and capabilities, you have to think about how this works under the hood, right? And by looking at the most important component of this vulnerability is the use of the DLL, apds.dll, right? And the way it is loaded into the system is completely, not completely, I'll say 90% evasive when thinking about how we are actually looking at DLL loads. So here I have the debugger, the X64DBG, and I'm actually debugging MMC as it opens the MSC files, right? So here we can see that APDS is loaded because I can see it on the memory map of MMC, but there's no other telltales in either the logs of the debugger or the call stack or anything else, right? So it's depending on how your EDR is looking at DLL loads, this will be completely blind to this specific technique, right? So it doesn't show on the module map, it doesn't show on the log of common debugger. So and this is because it's used just to locate strings. It's not actually loading the full DLL, okay? So remote app domain injection is another technique that's used for achieving remote code execution on a machine. So a little bit about app domain specifically and app domain injection. So net app domain, you can think of like a quirky sandbox when code can play. So when developing .NET executables, you kind of isolate the environment in which that module works, right? So App Domain Manager is kind of like the supervisor of the playground where this code can play, right? So the common language runtimes calls this manager when a .NET application boots up. It's now deprecated or no longer supported, but it's still there, right? Local app domain injection specifically has been known since 2020 and is categorized as MITRE ID 1574.014. So this specifically one, which is a local, meaning that you gotta have a file to be loaded, already dodges image load alerts and hides from Sysmon event ID 7. But the remote version, meaning that the payload that's going to be executed is grabbed remotely once the user executes, was found in 2024 in August, courtesy of APT 41, also known as Earthbaxia. And I'm going to show you guys right now how does this work. So it's another XML file, and here we can see that it's basically identifying an assembly, which is basically a DLL. And here's the href, basically saying, hey, load this JPEG, it's not a JPEG, it's a DLL, into the memory address of the MMC. And this is amazing, right? Because you can also, from the MSC file, from the XML file, sorry, tell the MMC subsystem to not do any logging. Great for stealthiness, right? So when doing the remote fileless AppDomain injection, if you want to replicate this, all you have to do to test your defenses, and this is what we do, you have to define my AppDomain manager here, a public sealed class, and you have to actually create a signing key for this. And once you are crafting the malicious XML file, those things must match, right? So you see here the public key token, the my AppDomain manager in green, and the public sealed class in yellow, okay? So now I'm going to hand off to Hossein so he can talk about what are the MSC of weaponization methods we have been seeing on the wild.
All right, thank you. Yeah, in this section, I'm going to talk about the different MSC weaponization methods that we have observed in the wild. So the first method, next slide, please. So the first method, and probably the most popular one and easiest one to implement, is using the console taskbar to run malicious command. As you can see here, you can specify the command line, the tool that you want to execute the command, for example, CMD or PowerShell, and then you can specify the command that needs to be executed by that chosen tool. Most of the threat actors usually disguise the MSC file with a custom icon to look like a document or trusted tool. And once malicious command runs in the background, a decoy document often opens to make it look legitimate and distract the user. Even though this method is really easy to implement, but it's noisy at the same time, it usually spawns a child process like PowerShell, which is something that detection systems are already looking for. The second method, yes. So the second method is a method that Doug already talked about a little bit. So this method involves exploiting CVE 2024-43572, which is a remote code execution vulnerability in Microsoft Management Console, and specifically through the component called APDS.dll. So in order to attack to work, it's like attackers need to create a malicious MSC file that reference a vulnerable internal web page within APDS.dll, and specifically through a resource named redirect.html. So using the specifically crafted URL as shown here, the attackers can inject JavaScript directly into MMC console. So as you can see, the format would be like something like this, apds.dll, then redirect.html, and target equal javascript.eval. This URL allows silent execution of the JavaScript within the MMC environment. And then the script uses the eval function to interact with MMC and is a scripting engine. And next slide. So we have also observed that threat actors started to become creative and obfuscate the crafted URL to evade static detection mechanisms. As shown here, they hex encoded the URL, which is making it less obvious for detection tools to look for. So when really decode that, you can see the familiar apds.dll. This simple obfuscation techniques helps payload bypass basic signature detection mechanism and still like achieving the same result. All right, next slide. The third variant, we call it Grim Resource Plus Plus, is this method usually abuse execute shell command method within MMC view object to run malicious commands on the victim's machine. It works by creating a malicious MSC file that embeds a shockwave flash object inside the ActiveX control, which by default open a web browser inside the MMC console. So when the browser loads, the content of the attacker control HTML page will be executed. In order for this attack to work, we need to define two key snapping. The first snapping will be linked to the web address snapping. This is the remote control page HTML. So the content of this page will be executed. And the second one is the ActiveX control snapping. Usually here is the CLS ID. Usually threat actors replace the CLS ID to which with like MSXML CLS ID that support XSL transform and JavaScript execution. In very simple setup, they can directly embed shockwave flash object or web a specific command such as like execute shell command into the web page. In that way, you don't need to specify the CLS ID. Next slide. This slide shows the distribution of these three methods that we have observed. As you can see, the most popular method is the first method. We called it shadow MMC. Around 51% of samples have used this method to weaponize their MSC files. The second popular method is the Grim Resource one that execute that abuse the APTS vulnerability. And as you can see, around 41% of samples have used this method. And among these samples, only 5% of them have used that obfuscation method that I mentioned in the previous slide. And finally, the third method, which we call it Grim Resource Plus Plus, is less popular, and only 9% of samples have used this method. Next slide. In this section, I'm going to talk a little bit about various APT and cybercrime groups that we have observed use MSC files as initial infection vector in their operations. Yes. So this slide shows the distribution of the samples by threat actor. As you can see, at least 9 known threat actors have used MSC files in their operations. Mustang Panda and Kimsuki are the most active one, responsible for around 30 and 25% of the samples, respectively. And following them, we have observed APT32, Patchwork, Mimeastic, Earthpaxia, and Beater also leverage MSC files in their operations. We finally, around 16% of samples, we were not able to attribute that, and it was because we didn't have the sufficient evidence to attribute them to a specific threat actor. This slide shows the distribution of the operation per month. As you can see, the very first operation was operated by Kimsuki around April 2024. And since then, we've observed the STD increase in the use of MSC files, reaching the peak around August and September 2024, where both Mustang Panda and Kimsuki the most active ones. Starting July and August 2025, other threat 2024. Other threat actors such as Earthpaxia, APT32 also began use MSC files in their operations. After August, we observed a STD decrease in use of MSC files and reaching the lowest point around February 2025. However, since March 2025, we observed somehow resurgence of using MSC files, particularly from Mustang Panda, who began using MSC files actively in their operations. And after March and April 2025, again, we observed that threat actors like using MSC files in the operation have been decreased. And this is because several new techniques have observed in the wild. For example, click fix became popular, and some of the threat actors, such as Kimsuki, started to use the click fix in their operations. Still, we observe some threat actors have used MSC files in their operation, even in October and November 2025, especially Patchwork and Kimsuki have used these MSC files in their operations.
Thank you very much, Hossein, but I will have to round up here. I don't know how many slides you still have.
Okay.
But it is time to go to the next presentation. Do you have any like final remarks you want to say to the public?
Well, I think Doug can a little bit like mention about the detection, but for a minute, I think it would be nice.
Yes. So just to finish here. So as we spoke, it's very complicated to identify these attacks if you don't know where to look, right? So setting up ETWs to look for suspicious DLL loads is a good one, but remember APDS won't look. I guess the best one is to basically look for MMC doing network activity or spawning new processes. And for AppDomain injection, as we saw on the XML file, you can instruct it to not do any logging. So I would instead look for memory heuristics on .NET processes, loading DLLs with page execute write copy. So it's the permission of the page, and looking for the syscalls that have been done on that DLL. So like create remote thread, decoding cryptographic payloads, so on and so forth. Thank you so much.
All right. Thank you very much for those closing remarks.
Thank you.
That was a very interesting presentation. It was a technical deep dive, of course, with a lot of code and a lot of things, but it is very interesting to see that stuff happening out there. So thank you for sharing. And I'm sure that more information is available online on the Fortinet website. And of course, you can also check out the full presentation in the resources for everybody to download. Thank you again, Douglas and Hossein, and I'm sure we'll see each other some other time.